Good day, amazing fans, and welcome to today's physics class. In today's physics class, we are going to look into this topic on the board, which says projectile motion. Okay, like I promised that I was going to make video explanation of what projectile is all about. So in our previous video, I explained what motion under gravity is all about. So from the motion under gravity, I think that will give us an opportunity to extend the knowledge to this word topic. Okay, so if today is your first time of coming across this page, please help us to like this post and share this video to get to a greater number of students on this platform so that they too can learn. Now, what is projectile? First of all, let's start with the word projectile. Talk about projectile. Projectile is an object thrown or projected into the air and allowed to move under the influence of gravity only. What does that mean? A projectile is an object thrown or launched or projected into the air and allowed to move freely under the influence of gravity alone. Now, when we say projectile motion now becomes the motion of an object projected into the air and allowed to fall under the influence of gravity alone. That is only. Good. Now, it is a motion of an object along a curved path. That means a curvilinear motion of an object. That is projectile motion. Now, for you to understand projectile motion, we are going to be looking at it under three headings. Okay. Since we said our projectile motion is a motion under gravity in two dimensions. So that means two motions are happening simultaneously. They are happening independently. But the one that is vertical motion is only affected by what? The gravity, which is the force of gravity. But the horizontal motion happens and remains the same. The horizontal projection velocity remains the same. Okay, now for us to understand this projectile fully, we are going to first of all look at when an object, case one, when an object is launched vertically upward. So we have what? Vertical motion. That is where we have vertical motion, okay? When an object is launched vertically upward, so we consider a projectile in that way. Then secondly, when an object is dropped from a height. So two objects dropped from a height. Object dropped from a height, okay, from a particular height above the ground. Then thirdly, when an object is projected with an angle of inclination, that means object projected with an angle of inclination with the horizontal or with the vertical. Projected with what? An angle theta. This angle theta is called or angle of inclination with what? Horizontal, with the horizontal or vertical. Now, you are going to be looking at projectile motion under these three headings. So the calculations differ. So under this. Now, when you look at this vertical motion, that means object projected from the ground to a particular height. This is what I treated in my previous video that I call it motion under gravity. Now, remember, we are now looking at the curvilinear part of what? The object. All right? Now, since we said that what? The motion of a projectile, it passes through what? A parabolic what? Path. What does it mean? Parabolic means for very curved. Now, if an object is projected, let's say at this point, you throw an object, you projected it here, let's say from here, it will move through a parabolic path. And this path in which the object travels is what we call the trajectory. This is called trajectory. This is the path where the object moves. The object moves from here, it moves, and it moves. And this here, we are seeing here, is in this case 3. And the object is projected with an initial velocity here. which is tangential to this. Now, projected with what? The horizontal. This is your theta. Now, we want to consider this projectile motion. Let's first of all look at this vertical motion. That means objects thrown to the what? The air. When an object is taken to a height, what happens? It will fall down back to where it is projected from. And as it's going up, we are moving against gravity. Then the object that is thrown up, it will fall down with an acceleration which is equal to 10 meter per second square or 9.8 meter per second square. This acceleration is known as acceleration due to gravity. Remember that the value of this acceleration due to gravity varies across the earth. Now, it is very great at near the what? The pole. So it's very great there. But during the equator, at the equator, the acceleration due to gravity decreases. So take note of that. Before we go into the analysis of the calculation, now let us look at examples of a projectile motion. When you throw a stone upward, you throw a stone thrown, or an object thrown up, it undergoes what? A projectile motion. Now, when you kick a football, like a footballer, like yesterday, Nigeria played the ball. Sometimes the goalkeeper takes the ball, then kicks it, or even the defender or any player kicks the ball. The path the ball takes before it landing, that path is what? Parabolic. So that is what? An example of a projectile motion. For example, an arrow that is shot from the bow, or where an arrow is shot from, the bullet shot from a gun, it will not go straight. It will move through what? A curved path, which is called what? Parabola. Then we also look at a javelin. In a sport, a boy or a sportsman throws a javelin. So the path through which that javelin moves is parabolic. That is also an example of projectile motion. Now, an athlete who is undergoing high jump, an athlete that what? Jumps. So when you jump, it's what? A parabolic path. So that is an example of projectile motion. There are instances, even a little boy who wants to shoot a bird with a catapult. You shoot the stone or whatever thing you put in that catapult, the stone shot from the catapult undergoes what? A parabolic motion, which is known as what? Projectile motion. So that path is what we call what? The trajectory. To move through that path. So projectile motion is what we call curvilinear motion because the object moves along a curved path. Okay. Now, we are going to be looking at how we carry out the calculations, the time it will take to get to the height, and the same time it will return to the ground. We are going to be looking at the velocity. Since we said that what? Motion under gravity is not a motion of what? Since we said that projectile is a motion under gravity in 2 dimensions, which means this projected velocity, we have the vertical component and the horizontal component. One of the 2 things you must understand in a projectile motion is that what? These 2 motions, they happen at the same time, but they are independent. The only motion that is affected by gravity is the vertical motion. The horizontal motion is not affected because there is no acceleration. When the object is thrown up, as it is landing, acceleration becomes 0. So where we have the acceleration, which is equal to the acceleration due to gravity, is the vertical motion. Now let us look at that case 1. When an object is projected vertically upward. Now this is the ground level. Let's assume this is the ground level. An object is thrown. And getting to this point here, the velocity v is equal to 0. And now at this point, the object will return back. As it's returning back, it's coming to the ground. Here, there is going to be a rebound velocity here. Now, since the body is dropping, the height becomes 0. This is the height here, where it was projected here, taken to a height. Now, at this point now, the final velocity of this, which is Vy, is equal to 0. Here, as you are going, it is projected with what? Uy. That is the initial velocity here, projected from the ground. Remember, we are considering vertical motion. So at this point, if I want to get the time it takes to get to this height, that is where we will use this motion, equation of motion, which is V equal to u plus at. Now, as you are moving upward against gravity, so your acceleration here become negative g. Since it is a vertical motion, we are working against gravity. Now, here, your v is 0 at this point, so we have 0 to u minus what? Gt. Now, we can take this gt to this side, gt equal to what? U. Okay, so from here, we can have this time equal to u over what? G. So this formula here is what we normally use for vertical motion. Remember when to use this. When you use this one is when object is going up, okay? And that t there, this small letter t you see here, is the time it takes to get to the height. Now, there is also another time that it will come back to the ground. When it is coming back to the ground, so that time now becomes the time of flight. So the time it takes to reach the maximum height and the time it takes to come down is always the same. That means the time of flight now is now equal to 2 times the time it takes to get to the maximum height. Okay. Now, if the object now that is released upward, then as it is coming back, remember I told you, as it is coming back, it's now falling freely under the influence of what? Gravity. So G now, A now become equal to plus G. So let's look at the second case where an object now, remember this one is where the object is projected what? Vertically for a vertical motion. But what if object is projected from a height and the object is dropped? Now what happens? Let's go. Now, if object was here before and this is horizontal plane, now object is dropped from a height here. Let's assume this is a height. An object is dropped. If an object is dropped from the height, it's dropped like this with an initial velocity, and this is called horizontal projection. This is called horizontal projection, and this velocity is not a vertical component of the velocity, okay? Because it is dropped from a height. Then at this point now, the u of y is equal to 0. So we only move with what? This what? Horizontal velocity. At this point, as it's coming down, it's coming. Then get to this point, we will have here the initial velocity, which is what? The horizontal projection. So this type of projection is called what? Horizontal projection. That is case 2, when an object is projected horizontally from a height. So at this point now, the range from here to here, this is called the range. And from here to here is the maximum height, okay? Now, what happens? For the objects to come to the ground, the time with which it will take to come down under this horizontal projection, that time is called the time of flight. Look at how we get it. We are no longer going to use this equation because this has nothing to do with this now. We are no longer going to use this u plus at. Now, since we are considering two independent motion, now let's look at this formula, the equation of motion that we know. If we say S equal to what? Ut plus half at squared. Now, in this case, your A is equal to what? As it's coming down, is equal to G, positive G. Then your S is equal to your H. That is what? The distance, which is the vertical distance here. That is the height. Then your Uy, remember we are considering Uy because it's a vertical motion coming down now. Your Uy is equal to 0. Now, at this point now, we will have acceleration as it lands on the ground here for a vertical projection. Acceleration here becomes 0, though the object was projected from a height, okay? So at this point, your acceleration becomes 0 on this ground alone. Remember, to get the range here. But now let us get our time of flight here, half at squared. So as it is coming from here, before getting to this point, that is where we use this formula. Now using that now becomes h equal to, because here uy, that is the initial velocity of what? The vertical component of the velocity. U of y is 0. Then it becomes 0 times t equal to half g, okay, that's plus half gt squared. So this one is 0. So your h is equal to what? Half gt squared. Now this time of flight now can be calculated as, that's gt squared equal to 2h. So here your t squared is equal to 2h all over what? G, which means t is equal to the square root of 2h all over g. So this is your time of flight for what? A body projected horizontally from a height, from the top. Remember I told you that at that point, the vertical velocity, the initial velocity of what? The vertical component of this projection is what? 0. Now the object is only moving down, coming down without a horizontal velocity of projection, which is this what? Ux. Now for us to get the time of flight, we make use of this formula. And now acceleration here is equal to g. Now what if the body now lands here? That is where we have the range. As the body lands here, that means acceleration becomes 0 at this point here. This is the level, this is the point of projection, starting from here. Then coming down to this here, this becomes the level of projection. So the measurement, the distance from the landing point, from the foot of the cliff, gives us the range. And now, how do we get the range? Range is the horizontal distance, which is Sx. You see the same thing I'm saying? R is equal to what? Ux multiplying the time of flight. And remember, this time of flight now becomes this one, of this motion. So which is equal to Ux times the square root of 2h over what? G. Remember, this one is for horizontal projection from a height. But what if we project with an angle, which is what? Inclined, or project with initial velocity inclined at an angle with the horizontal and or vertical. Now let us look at how we get the time to reach the maximum height itself, and also the time of flight, also the range. So here, this is the maximum height. Your maximum height is this formula, which is equal to what? Half gt squared. Once you know the time of flight, once we calculate the time, so this is the maximum height for that of what? Horizontal projection from a particular height. And remember, when you take an object upward, the maximum height becomes, which is this your v at 0. V is equal to 0 here.